William has a tendency to drop his bowling ball on release. Instead of having the ball on the floor at the completion of the swing, William lets go of the ball at 0.35 meters above the floor. The second we go to start something like this, we should instantly go ahead and create our list of given variables here. So our chart really. So we're going to have delta x, v naught, v, a, and t. Let's call this x. We'll call this y, horizontal and vertical. We'll go ahead and fill this out with the information that we know. Okay, he lets go of the ball 0.35 meters above the floor. So that's vertical. It's up and down. 0.35, but it's got to go down, so it's negative 0.35. I'm not going to include my units or anything in this chart. What we do know is anytime you drop something, its initial velocity, and that's pretty much what he's doing with the bowling ball, the initial velocity is in fact 0. The acceleration is negative 9.8 meters per second squared. Vertically. Horizontally, it's going to be equal to 0. No acceleration horizontally. Okay, if William throws the ball horizontally at 6.3 meters per second, how much time is the bowling ball, how much time until the bowling ball hits the floor? So we do know our initial velocity over here is 6.3. We now have all of the information right here in our chart, and everything I notice is, well, this side has a little bit more than this side, right? So I like using this side. I think it's a better idea to start with for this problem. Okay, if I'm looking for time, I need to choose the equation that would work best for me. I have delta x. I don't have final velocity, and right now we don't necessarily care about it. So this is in fact going to be, start in the y, and we are going to be using the delta x is equal to v naught t plus 1/2 at squared. We can then plug our numbers in there. Negative 0.35 is equal to 0. We don't care about this. It's t plus 1/2 negative 9.8 t squared. This goes away. We're left with negative 0.35 is equal to 0 plus negative 4.9 t squared. I'm going to divide by negative 4.9 on both sides. Okay, t squared is equal to, well, I don't know that off the top of my head, so I'm going to go ahead and plug that into my trusty dusty calculator here. I got negative 0.35 divided by negative 4.9. I get 0.071. We're not done. We want t, so I'm going to square root it. And t will be equal to, look, my fast way of doing it, second square root, second answer, 0.27 seconds.